This is 8.4, day 2. We're going to factor apart our numerator. This is x minus 5. Factor apart the denominator. You can break that into two binomials. X times x gives you x squared. 5 and 2 multiply to be 10. You need a negative 5 and a negative 2 to add to be negative 7. So your x minus 5's cross out, and we're left with an x over x minus 2. That would be fully factored. The x's cannot cross out. The rule for multiplying rational expressions is the same as a rule for multiplying numerical fractions. We're going to multiply the numerator and we're going to multiply the denominators. And then we're going to write it in simplest form. So in this case, your A times your C, this should be a B, I believe. So when we multiply those together, let me see here. A times the C and the B times that, nothing crosses out, so it's good to go. On this case down here, we're going to multiply, and we're going to get 30, because 5 times 6 is 30. X times x, you add the exponents, so we get x cubed. You get y cubed. On the bottom, 2 times 10 is 20. X. You got 2 y's here and 1 y there, so you got y cubed. Now you can cross out all the y's. You can cross off one of the x's, and you can reduce your 30 and 20 down to 3 and 2. So your final answer is 3x squared over 2. Simplified answers are written in completely factored form. To simplify it, it has to be factored. On the second page, here's your formula for the sum of two cubes. If you have two cubics that are being added, you take the cube root of each of those numbers, and then you square the first term, you multiply the two together, and you change the sign, and you square the second term. You can always check this out by distributing through the A and then distributing through the B and collecting your like terms. You're going to end with what you started with. So we're going to try that over here. We have x minus 4. We have an x cubed, plus we have a 2 cubed. That's the sum of two cubes, times x squared minus 2x plus 4. So I'm going to factor the bottom. I'm going to call that x plus 2. I'm going to square my first term. I'm going to multiply my other two together and change the sign. And then I'm going to square my second term. And that should still multiply my x squared minus 2x plus 4. And in this case, they cross out, and I'm left with x minus 4, x plus 2. Nothing can factor out of this last expression. The x's can't go, the 2's can't go. Here we're going to do a GCF to the top. 3x, x minus 1. We can factor the bottom into two binomials, x and x. Looks like that multiplies to be 5, so that's 5 and 1. You have to add to be a positive. You need more positives, so the 5 is positive and the 1 is negative. On this side, we're going to look at factoring that apart. We'll get x and x. We'll get 5 and 4. That multiplies to be 20. You need more positives. You need a positive 1 to be left over, so positive 5 and a negative 4 with the 3x on bottom. Now we go into crossing out mode. We're going to cross out our x plus 5 with our x plus 5. We cross out x minus 1s. We cross out our 3x's, and we're left with an x minus a 4, and everything else is crossed off on bottom. So you don't need to put that over 1 if you don't wish. X minus 4 is your correct answer. We're going to factor the top, the GCF. You can factor out a 5x, and you're left with 4 minus x. The bottom, you're going to factor out an x, and you're left with an x minus 1. The top is an x and an x, 4 and 1. You need more positives, and a negative 1 to multiply to be a negative and add to be a positive. And the bottom is the difference of perfect squares. This is x squared minus 4 squared. So this is going to turn into x plus 4, x minus 4. The order of those don't matter. You can cross out your x minus 1s. You can cross out your x plus 4s. You can cross out your almost here, right? You have x minus 4, but this is a positive 4 and a negative x. We can rewrite that as positive x, negative 4, if we bring a negative out in front. So I'm going to cross out that, and I still have my negative or negative 1, so I have a negative 5 after my x's cross out here. So I'm left with only a negative 5. That was a tricky move. You had 4 minus x. You had to switch that over to an x minus 4 by factoring out the negative. That would change both signs and leave you with a negative 5. Next, we're going to talk about dividing rational functions or rational expressions. We're going to take one fraction and we're going to divide it by another. What you need to do is multiply the first rational expression by the reciprocal of the second. So we don't actually divide fractions. We multiply by the reciprocal. So here, if you're going to have a over b divided by c over d, that would be one way to have it written. That's the same thing as AB divided by CD. We don't divide the fractions. We multiply by flipping this fraction over. Now you get AD times BC. You multiply straight across. You don't cross multiply here. There's no equal sign in the middle. So in this case, we're going to multiply by the reciprocal, 3 over 7. We multiply the 2 and the 3, the 5 and the 7, and you get 6 over 35. In a more complicated looking problem, this might start out looking like 7 over x plus 1 all over x plus 2 over 2x minus 3. It would start with this. We would be able to write it with the division sign of the x plus 2 over 2x minus 3. You don't divide the fractions. You multiply by the reciprocal. So you put the 2x minus 3 on top, the x plus 2 on bottom. You leave the first fraction, the top fraction, alone. Now you multiply straight across. 2 times this guy, and those two multiply. You may leave it separated. You don't have to physically multiply those together. So let's try one. We're looking here. We're first going to factor that apart. We're going to say x and x, 7 and 3. You need more negatives than positives. You're going to factor out your 5, and you're left with x plus 3. Now we're going to multiply by the reciprocal. So we're going to take our denominator, which is x minus 10, x plus 10. That goes on top, because when we divide fractions, you multiply by the reciprocal, so you flip the second one around. We have x and x. Looks like 7 and 10. What multiplies to be 70 and adds to be 3. So this is going to be more positives because it adds to be a positive, and a negative 7. So those can still cross out. These can cross out. X plus 10s can cross out. And you're left with x minus 10 over 5. Nothing can reduce here. You cannot reduce the 10 and the 5. Here we're going to do the same idea. This is a little bit more tricky with a leading coefficient of 3. So what I like to do, I like to make a table. What multiplies to be negative 30 and adds to be 13, that's going to be 10, 15 and 2 actually. 10 and, let's see, 10 and 3. The signs have to be different because it's multiplying to be a negative. So you couldn't get 13 out of that. So it's got to be 15 and a negative 2. Now the signs are different and it adds to be 13. So we're going to take our 3x squared plus 15x. We're going to take this 15 and make it 15x minus 2x minus 10. So we're taking our numerator and we leave it with the 3x squared. We write the 13 as 15 minus 2 and we leave the 10. We factor by grouping like we did in an earlier lesson. 3x with an x plus a 5. Bring down your sign, factor out a 2, and you have an x positive 5. Careful on that. A lot of people mess this up. Negative 2 and a positive 5 make a negative 10. What's inside the parentheses are exactly the same. So you have 3x minus 2 and you have x plus 5. We have just factored apart the numerator. So we're going to say that this is 3x minus 2, x positive 5, with 6x squared in the denominator. This guy is currently over 1, so when we multiply it, we're going to say it's 1 over, and we can factor that guy apart some. We're going to factor out our x, and we'd have a 3x minus 2 sitting inside there. Those can cross out. Nothing else can cross out here, so we have our x plus 5, and we have our 6x cubed. Nothing else here can be reduced. Last problem. This is the difference of two cubes, so we're going to take x minus 1. We're going to square that, so we get x squared plus the 2 multiplied together. Square the last term, so 1 times 1 is 1. Here, we have a tricky cubic again, so we have a leading coefficient of 2. So off to the side, I'm going to factor those. We're going to look at 2 times negative 3. That's negative 6. That adds to be a positive 1. You could also do this by guess and check. It's probably faster. So we're going to try to figure out what multiplies to be this. So you could say negative 1 and 6. You could say negative 2 and 3. This one adds to be the positive 1. So we say 2x squared minus 2x plus 3x minus 3. So we brought the 2x over. We brought the negative 3 over. And we used our negative 2 and 3 to represent our x for the middle. Then you factor out your terms. 2x, x minus 1. Factor out your 3, x minus 1. So 2x plus 3, x minus 1. Guess and check is great, but if you have troubles getting the guess and check to work, this is always pretty flawless if you don't make mistakes. It'll always lead you to the factored form. This is over 1, so we're going to multiply it by 1 over x squared plus x plus 1. What multiplies to be 1 and adds to be 1? 1 times 1 is 1, but that adds to be 2. So this is not factorable on bottom. So those are going to cross out. These are going to cross out. And you're left with 1 over 2x plus 3. The final note for today is that in the homework, you're going to need to use the formula of a cone, which is 1/3 pi r squared h. And the volume of a pyramid is 1/3 the entire base, the area of the base, B stands for the area of the base, times its height.